Keep the integer part as it is. Take down the fractional part, that is 0.50 into 2. Then we are getting 1.00. The fractional part, now it becomes 0 here. If you observe here, the fractional part, now it becomes 0. That's why now we have to stop processing. For the fractional part, write down from top to bottom. For integer part, from bottom to upward direction you need to write. Welcome back to One and All. Myself, Vasanta, lecturer in Computer Science, Vidhyaashram, Pre-University College, Temple of Excellence, Mysore. Today, we are going to start with the third session of Data Representation chapter. Whereas in the previous class, you have studied regarding number system conversions, that is decimal to binary, decimal to octal, decimal to hexadecimal conversions you have studied. That means without using any fractional part, only for the integer part, how to convert a decimal number to binary number, decimal number to octal number, as well as decimal number to hexadecimal number. Whereas on today's class, you will come to know decimal fractions to binary. Whereas in the previous class, only decimal number to remaining bases you have studied. Whereas on today's class, decimal fractions to binary, decimal fractions to octal, decimal fractions to hexadecimal. It means that only for the fractional part, how to convert the decimal number to the remaining base value, where it may be binary, octal, or it may be hexadecimal. Now, consider here decimal fractions to binary or octal or hexadecimal, then we have to follow some rules and regulations. The first one, the fractional part is multiplied successfully by the given base value. It means that only for fractional part, you have to multiply by 2 or 8 or 16. If you want to convert to binary, then multiply by 2. If you want to convert that into octal, then multiply by 8. If you want to convert the fractional part into hexadecimal, then multiply by 60. Then in the second step, collect all the numbers to the left of decimal point. Collect all the decimal points, that is integer parts. This process is continued until the fractions become 0. The fractions become 0 or the number of up to sufficient accuracy. Until we get to the fractional part has to be 0 or particular accuracy value, or the fractional part starts recursive. That means same recursive value if you're getting. Repeatedly if you're getting the same value, till that you have to process. That is, the fractional part may be 0, or it may be sufficient accuracy value, or it may be the fractional part become recursive. Recursive means repetition. Till that you have to process. Then the result obtained by writing integral part from the top to bottom wise. Like this, we have to follow the steps if I want to convert any decimal fractions to binary, octal, as well as hexadecimal. Now is it clear? Now we will explain with some problems. Consider we have the number 138.3125. It is a decimal number. If you want to convert this into binary format, first the integer part only we are going to take, that is 138 divided by 2, then 69 the remainder is 0. Then 69 divided by 2, then 34, remainder we are going to get 1. Then 34 divided by 2, 17 will get with the remainder 0. Then once again if you divide this 17 by 2, 8 the remainder is 1. Then once again we will divide this 8 by 2, then 4, remainder is 0. Then divide this 4 by 2, then 2 the remainder is 0. Then 2 1 the remainder is 0. For integer part, we will follow the division process only. See here on which base we want to convert, by that number we will divide. But for fractional part, how to find out? Consider only the fractional part, that is 0.3125 into 2. Which base you want to convert? For that number you have to multiply. If you want to convert to binary, then 2. If you want to convert to octal, multiply by 8. If you want to convert that into hexadecimal, then multiply by 16. Then when you multiply, then we are getting 0.625. Then keep the integer part as it is. Then take down only the fractional part. That is 0.625. We are going to take, once again multiply by 2. Then we are getting the integer part is 1 and the fractional part is 0.25. It means that once again the fractional part is not become 0. Then take down the fractional part once again, that is 0.25. Compulsory, you have to take the fractional part, that is 0.25 into 2. Then we are getting 1.50. Keep the integer part as it is, take down the fractional part, that is 0.50 into 2. Then we are getting 1.00. The fractional part, now it becomes 0 here. If you observe the step, this process will continue until the fractional part becomes 0 or particular accurate value, or until it becomes the recursive value. Here the fractional part becomes 0. Now we have to stop processing. But while writing the integer value, you have to write from top to bottom. Then the result will be here. See, first I will write 1, 0, 1, then once again 1 and then 0 we will write here. Next, we will explain with some more problems like convert 138.3125. Then for integer part 138, then divide by 8, 17 is the remainder is 2. Then 8, 17 once again will multiply, division process. Then 8 2 is 16, remainder 1, note down the remainder. Then take down the fractional part, that is 0.3125 into 8. Because our agenda is to convert the result, especially decimal number to octal, then multiply by 8, then we are going to get 2.5. Take down the fractional part, that is 0.5 into 8, then the result you are going to get 4.0. If you observe here, the fractional part, now it becomes 0. That's why now we have to stop processing. Then the result you have to write 212.25. In the base 8 we will write. Now is it clear? Same format, consider one more problem, 138.3125 to hexadecimal. It means that here 138, when I divide it by 16, then 8 is a remainder 10 we are getting. Here don't write 10 as it is while writing the result. You just replace all the values, that is 10, 11, 12, 13, 14, 15 by the corresponding alphabetic order. That is, for example, in hexadecimal number you have the value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, you have to write A, B, C, D, E, F. Whereas A represents 10, B represents 11, 12, 13, 14 and then 15. Then on the place of A, especially on the place of 10, you have to write it as A here. Then 8A point. Here if you observe here, take in the fractional part 0.3125 into 16. Then we are getting 5.0. Then in the first iteration itself, we get the result as 0. Then no need to process, stop the processing. Then the result will be 8A.5 in the base 16. Now is it clear for all of you? It means that if I want to convert any decimal number to binary, especially if it is integer part, then divided by 2. If I want to convert any decimal number to octal, division process but divided by 8. In the same way, if I want to convert any decimal number to hexadecimal number, divided by 16. If I have the fractional numbers, decimal fractional numbers, on that case, especially for fractional part, if you want to convert that into binary, multiply by 2. If you want to convert decimal fractional part to octal, then multiply by 8 with the fractional values. Here the fractional value multiply by 8. Then if you want to convert the decimal fractional part to hexadecimal, then multiply by 16. Integer part, division process will perform, whereas for fractional part, we will perform multiplication process. Here what we have done, we want to convert the decimal fraction to hexadecimal. That's why the fractional part we have multiplied by 16 and note down the value. Now is it clear for all of you? Next, consider we have the number 422.75. It is a binary decimal number. If you want to convert that into binary format, then once again division process, 422 divided by 2, then 211, remainder 0. Once again divide by 2, then 105, remainder 1. Divide that 105 by 2, then 52, remainder is 1. Then divide this 52 once again, then 26, remainder is 0. Then divide this 26 once again by 2, 13, remainder 0. Divide this 13 by once again, then 6, remainder 1. Divide this 6 once again by 2, 3, remainder 0. Then 3, 2 ones are 1, remainder is 1. Note down the values. Then for fractional part, take down 0.75 into 2. Because our agenda is to convert the given decimal number to binary format. For the sake, divide that number. Especially if it is integer part, division process. For fractional part, multiplication process. Then 0.75 into 2, then we are getting 1.5. Then once again take the fractional part 0.5. Don't consider 1.5 because you have to consider only the fractional part. The fractional part here we are given 0.5 into 2. Then the result we are getting 1.0. Now the fractional part becomes 0 here. If it is 0, then no need to process. Then write down the value here. We have the 1 value. Then here 1. Then 0. Then 1. Here once again 0. Here once again 0. Then here 1. Then here also 1. Then finally here 0. From bottom to upward direction we are written. Whereas here this value, first I have to write this one here. Then next write down this one here. It means that for the fractional part, write down from top to bottom. For integer part, from bottom to upward direction you have to write. Now is it clear for all of you? Now we'll explain some more problem. For example, 422.640625. It is a decimal number. In the base, they are not given any value, but still it is assumed as decimal value. Because in default, in the base, if you not write any value, then it is considered as a decimal number only. To octal number, then take down the integer part, that is 422. I want to convert that into octal format, then divide by 8. Then 422, when I divide by 8, then 52 the remainder is 6. Then once again divide this 52 by 8, then 6 the remainder is 4. Then here we'll write the value 6, then 4, then once again 6. Take down the fractional part, that is 0.640625 into 8. Then we are getting 5.12. Consider only the fractional part once again, 0.125 into 8. Then we are getting 1.0. Now the fractional part becomes 0. That's why no need to process. In this case, in the second iteration only, it is stopped processing. But while writing the value, write down this 5 first and then 1 next. That means you have to write from top to bottom, here bottom to upward direction. Consider one more problem. Convert 422.42 to hexadecimal. Then here integer part, I want to convert that into hexadecimal. That's why multiply the fractional part by 16, divide the integer part by 16. Then 422, when I divide it by 16, 26 the remainder is 6. Then once again divide this 26 by 16, 1 the remainder we are getting 10. Already I told you in the previous problem, if I want to write 10, then the equivalent hexadecimal number is A here. Then take down the fractional part, that is 0.42 into 16. Then when I multiply, then 6.72 I am getting. Take down the fractional part once again, then multiply by 16. Then 11.52 I am getting. Then once again, take down the fractional part, that is 0.52 into 16. Then I am getting 8.32. Once again, take the fractional part and then multiply by 16. Then I am getting 5.12. If you want, you can continue the process because the fractional part here, it is not 0. But minimum 4 iterations you have to do, and then if you want, you can stop processing. That's why here I consider up to 4th iteration only. But while writing the value, here we have 1 and here 10 represents A and 6 here. But if you consider the fractional part, here we have 11. That 11 cannot be written directly here. Just replace A by 10, B, C, D, E, F. This represents 11, 12, 13, 14 and then 15. It means that here 6 as usual will write. The 11 we will replace by B here. Then next 8 and then 5. Now is it clear? It means that I can able to convert the integer part as well as fractional part to any other basis. The main thing you have to remember is decimal number. If it is decimal number to other bases, for integer part, you have to do the division process. For fractional part, you have to perform the multiplication process. Next class, we will explain regarding how to convert the remaining bases like binary, octal, hexadecimal to decimal format. The reverse, whatever thing today we explained. In this class, you come to know regarding decimal to other bases, where it may be binary, octal, hexadecimal. Whereas next class, you will come to know regarding from binary to decimal, octal to decimal, as well as hexadecimal to decimal, how to convert if you have only integer part. Otherwise, if you have a combination of integer and fractional part, regarding that next class, you will come to know. Thank you for all of you.